Hi everybody, welcome back. We're on day 3 of notes. This is our third night of homework for unit 1 and 2 when we're talking about expressions and equations. So today we're going to be talking about the properties we use to solve equations and actually how to solve a 1 and 2 step equation. Okay, let's go ahead and get started. Now I'm going to warn you right now, unfortunately there is a little bit of writing. Luckily you don't have to make the whole table, but there is a little bit for the description, so just bear with me. This is probably the most that you're going to have to do for the notes, but if I'm going too fast, just go ahead and pause the video. Most likely you're going to have to pause the video a couple times so you can get it all down, okay? So, let's go ahead and talk about these properties. Most of them you've seen before, like commutative, associative. You've seen them before, so a lot of this will be just a review for you. There are some of the properties that you'll have seen for the first time today, and we'll talk about those and how to use them and so on. Okay, so let's go ahead and jump into the stuff that we already know, commutative property. Now, commutative property happens over addition and multiplication. With addition, it's just changing the order of the addends. Okay, and here's an example, a plus b equals b plus a. Well, all I did was change the order of the a and the b. Those are the addends. That's the stuff that you add together. We'll just change the order and it's still equal to each other. Okay? With multiplication, it's the exact same thing. I'm just changing the order of the factors. That's that's the stuff that we multiply together. These are called factors. So a times b is going to be equal to b times a. Okay? That's just commutative property. Remember, think of it like commuting back and forth to work and school or to school and home. Commuting going back and forth, and it's still going to be the same thing. Okay? Next property is associative property. Again, it's over addition and multiplication. So over addition, it's just changing the grouping symbols. And actually that's the same thing you can put for multiplication. If you just want to do those little tick marks, it's like it looks like one part of a quotation mark. Underneath it, you don't have to write it twice. But we're just changing what's in the grouping symbols. As long as everything in the expression is addition or everything is multiplication, we can move these parentheses around to be over 2 of them, and it'd still mean the same thing. So here I have a plus the quantity of b plus c, but that's going to be equal to if I said the quantity of a plus b plus c. Okay, remember this is like grouping symbols, so if we were solving this, we'd have to do b plus c first, then add a. Wouldn't make a difference though, because we could do a plus b first and then add c. We'd still get the same answer. And the same thing goes with the multiplication. A times the quantity b times c is going to be equal to the quantity b times a times c. Okay? Those are the two easy ones. You guys have probably already seen them before. So let's go on to identity property. Again, over addition and multiplication. The reason a lot of these are over addition and multiplication and not subtraction and division is because, think of it like subtraction is really adding a negative. So technically we could do it over subtraction, but we couldn't change what's negative. Does that make sense? So if we had, for example, if we had a minus b, well really we could say that's a plus negative b, which means we could change it and say like negative b plus a, and that's going to be the same thing. We couldn't change what's negative though. The b still has to be negative. So if you want more of an explanation on that, I can definitely show you in class. It's going to be easier to visually see it, but just go ahead and raise your hand in class if you'd like an example of how we can use, like how associative, commutative, identity, all that stuff works over addition, not addition, subtraction and division. Okay, because it kind of follows the same rule with division, is that dividing something is really multiplying by like a fraction. Okay, so if you want a visual for this, just ask me in class. I can gladly go through it with you. Okay, but identity property for addition, it just means that the sum of a number and 0 is the original number. Okay, that's all identity means. It means that if you add something with 0, you're going to get that same number out. Okay, and same with multiplication. Instead of a sum, it's the product of a number and 1 is going to give me that number again. So a number times 1 will always give me that 1 number. Okay, next one is inverse. Inverse you're going to see a lot of. Okay, you're going to use inverse a lot. So again, it's over addition and multiplication. Inverse just says the sum of a number and its opposite equals 0. So a plus negative a equals 0. And then with multiplication, it's the product of a number with its reciprocal, not opposite, reciprocal, so you have to flip it, make it into a fraction, equals 1. So a times 1 over a equals 1. Okay? And the distributive property we already know, it's a number multiplied with the sum or difference gets multiplied with each added in. Sorry, that was a really wordy way of saying it, but basically here's the picture, the algebraic description, which I find easier. A times b plus c means it's going to be a times b and a times c as well. And even if that's subtraction inside, it does the same thing. This is not distributive property if the numbers inside the parentheses are being multiplied together. It's only over addition and subtraction. Okay? So make sure you know that. Alright. And then the last one, sorry, it's not in the table, I forgot it before, but it's a multiplicative property of 0, which just says if you multiply a number with 0, it's going to equal 0, always and forever. Okay? So that's the first page. I'm sorry if you had to pause it and I went too fast. It's like one more page of this stuff, and then the rest is really easy math for you. Okay? Let's go ahead on to the next one then. So the properties of equality. This is probably something new to you. You guys probably haven't seen it written out before. I guarantee that you've used this stuff though before. Okay? It's kind of basic stuff. It's really, really like common sense. It's just now we're putting a name with the common sense. Okay? We want to make sure we know the names of all these properties, because when we have to go through steps, every step has a reason for it, and we need to be able to name these reasons. Okay? So these are properties of equality, which just means that these properties will be used to show that something is still equal when we're solving equations. Okay? First one is reflective. And let's see. Okay, so it just means that a number is equal to itself, like a times a. Think of it like it's a reflection in a mirror. If the equal sign was a mirror, you see exactly that. Okay? Symmetric property says that the order of equality doesn't matter. So if I have a equals b, I could write it the opposite way and say that b equals a. Okay? The way that you write it around the equal sign doesn't matter. The order, what comes before the equal sign, what comes after, that doesn't matter. It's still going to mean the same thing. Okay? Transitive property says that two numbers equal to the same number are also equal with each other. So, look at this. This is going to be easier. Think of a train kind of when you hear this. If a equals b, so train goes from Washington to New York, and b equals c, so from New York to Canada, then a equals c as well. So that means that train was going from Washington to Canada. Okay? So you get on a train in Washington, D.C., you go to New York, then you go off that train onto another train in New York, and you go to Canada. Really, you went from D.C. to Canada, right? It's just saying if a equals b and b equals c, a then must equal c. Okay? Alright, substitution. You guys have used this a lot. Now we just have a name for it. It just says that a number equal to, that is equal to an expression can replace that expression. Whether that expression is like 2 terms, 4 terms, or just 1 term, we can replace it with that number that it's equal to. Okay? So here it says if x equals y, means I can replace y, I can put y in for any x and it would still be equal. Okay? Same thing if I had like 4 plus 3, I could substitute in 7 for that and just completely get rid of that 4 plus 3 and just have a 7. That's all substitution is, basically doing the math. Addition of equality. So here we have the next 4, addition, subtraction, multiplication, and division of equality. All these are saying, sorry, these are the wordy ones. I'm so sorry. It's basically the same thing. All it is I changed, like, if it's addition, subtraction, multiplication, and that stuff. Sorry. But addition of equality. If you add something to one side of an equation, you must add something to the other side in order to keep it equal. So if I have x equals y, and that's an equation, and then I need to do x plus z, I have to do y plus z in order to make it equal. Okay? Same thing for subtraction. If you subtract something from one side, you must subtract it from the other side in order to keep it equal. So we went from x minus z, it also has to have the y minus z on the other side. multiplication of equality. If you multiply something on one side, you have to multiply it on the other side to keep it equal. So I had x times z, I need to have a y times z as well. And division, same thing. If I divide something on one side, I need to divide it on the other side to keep it equal. So if I divided the x by z, I have to divide the y by z as well. Sorry, that was really wordy. I couldn't figure out a quick way of saying it. Sorry. So, clearly I'm pretty sure you've paused this video multiple times now, but that's the majority of the writing. The rest of the stuff is like quick math. So we're about halfway done now. So yeah, let's go ahead on to the next part. Okay? Those are all the properties, by the way. Now we're going to go into solving 1- and 2-step equations. Now in order to solve an equation, we must blank the variable. That's right, isolate the variable. Okay, we are always trying to get the variable by itself so we can figure out what it's equal to. Okay, and in order to do that, we do this by undoing, I forgot the ing, the operations that are there, and we do it in the opposite order of GEMDAS. So take GEMDAS and do it backwards. This is the order we get. We do subtraction and addition. We undo those first. Okay. Then we can undo any division and multiplication. Then we can undo any exponents. This is all the operations that are happening to the variable. So we undo any addition or subtraction that is going on with the variable. Then we can undo any division or multiplication that's going on with the variable. Then we can undo the exponents that are happening to the variable. Then we can undo any groups that the variable is within. Okay, and we'll talk about these during examples. But the way we undo the steps, or I'm sorry, the operations, and how we solve equations is the anagram SADMAG. So you're going to hear me say SADMAG it a lot. It just means that's how we're going to take it step by step on how to undo the operations. Okay? All right, so let's go ahead and try a couple of examples. Right? So number 1, it's a 1-step equation. Okay, because there's only one operation happening to the x. So we're trying to get this x by itself. Okay, and in order to do that, we have to undo the operations that are happening to the x. So what's happening to the x right here? Well, it's being multiplied by 4. So to undo 4, how do I undo 4? I divide. Or I'm sorry, how do I undo multiplication? I divide. So here, I just write it out. 4x is now going to be divided by 4. And if I do that to one side, I have to do it the other side to keep it equal. That's the division property of equality. Okay? So now I can go ahead and do this. 4x divided by 4 leaves me with 1x. Okay? 1 divided by 4 leaves me with 1/4. Okay? 1 times x just leaves me with x. 1/4 just stayed the same. So x equals 1/4 is my final answer. Okay? Second one, 4/5 m equals 28. Well, what's happening to the m? It's being multiplied with 4/5, so I can divide by 4/5 on both sides. 4/5 divided by 4/5 leaves me with 1, so I have 1m. 28 divided by 4/5 gives me 35. Okay? So 1 times m just leaves me with m equals 35. This way, I find it to be a little bit more complicated because I'm dividing by fractions. And that's kind of hard to do in the calculator and by hand. Okay, so I'm going to show you another way to do these kind of problems. When you have a coefficient that's a fraction, there's another way. Okay, so instead of dividing by 4/5, what's another way I can get 1? I can change the 4/5 into a 1. Not just dividing by itself, but I could also multiply by its reciprocal. 4/5 m times 5/4. 5/4 times 4/5 will give me 1m. Okay? So if I'm going to multiply by the reciprocal here, this is like the inverse of multiplication happening. I gotta multiply by 5/4 on the other side as well. So this will actually give me 1m. I still get 35. 1m is still going to give me m, and it's still going to equal 35. It's the same thing. This is a little bit easier to see, like the inverse property happening. Okay? So I would suggest you do this when you have a coefficient that's a fraction. Okay, just multiply by the reciprocal. It's going to be easier for you. Okay? Just keep that in mind. You're going to have to do one on your own. All right? Next one, here's a two-step. I have two operations happening here. I've got multiplication with the r, and I've got 1 being added to that r. Okay, so we follow SADMAG. I undo any subtraction or addition first. So I have to undo this addition. How do I undo addition? I subtract. So I have to subtract 1 from both sides. Okay, so I have 3r plus 1 minus 1 equals 16 minus 1. I can go ahead and do this 1 minus 1. I get 0, leaving me with 3r. 16 minus 1 gives me 15. All right, so now I just have 3 times r. I have to undo that times 3 to the r. So how do I undo times 3? I divide by 3. Okay, so now I have 3r divided by 3. 3 divided by 3 will give me 1r. 15 divided by 3 will give me 5. 1 times r just leaves me with r. So r equals 5 is my final answer. Okay, and our last one, I want to say this one's a little bit trickier just because it's got a common mistake that happens a lot with it. Okay, so let's look at it. Negative 12 equals x minus 7 over 3. Okay, now SADMAG says undo the subtraction before undoing the division, right? But here's where the mistake happens. This is where you really need to know GEMDAS, okay? X minus 7, remember when that's a fraction, when there's an operation on a fraction bar like that, that's a group, right? So I can't really subtract 7 because that 7's not really a 7, it's a 7 being divided by a 3. Okay, so that's when the x is part of a group. So groups for SADMAG happen at the very end, so I have to leave that all alone until it's by itself. So actually the first thing I'm going to do is take care of this divided by 3. And how do I undo divided by 3? I multiply both sides by 3. Okay? So this divided by 3 and this times 3 cancel each other out, leaving me with just the x minus 7. And negative 12 times 3 gives me negative 36. Oop, I skipped a step, sorry. Okay? So the 3's just canceled each other out, that's all. So now I can undo the subtraction because that's the only thing happening to the x, and it's no longer in a group anymore because the fraction was taken care of. So to undo that subtraction by 7, I add 7 to both sides. Then the plus 7 and the minus 7 cancel each other out, so I'm leaving myself with x over here. Negative 36 plus 7 gives me negative 29. And then I could leave my answer like this, that's totally fine. Or I can flip it around. And that's, remember, that's the symmetric property that says you can go ahead and flip it and they still mean the same thing. Okay, so either of these answers would be acceptable. All right, so go ahead and try these 4 on your own. Pause the video, and when you come back, I'll have the answers for you. But they're the same extent of difficulty as the ones we've done, so make sure you look back at your notes just to check and make the steps out, okay? Alright, so go ahead and pause the video and I'll have the answers for you when you get back. Alright, so hopefully you were able to solve them all. And let's go ahead and check our answers. So 19 equals r over negative 3. That actually equals, r is equal to negative 57. And I can always check my answers, by the way. If I know what r is, this is basically, I just came up with a substitution set for myself. So I can plug in negative 57 into r and divide it by negative 3, I should get 19 then. Okay, so all I had to do is take my answer, plug it in the variable, and then simplify both sides. I should have both sides equal to each other then. Okay, so that was an easy way to check your answer, and you can do that check in the calculator too. Just check them both on each side, and you should have the same number. Okay. Next one, 7/10 x equals 21, so I can multiply both sides by the reciprocal. The reciprocal of 7/10 is 10 over 7. And I get an answer of x equals 30. Okay. Here, 2x plus 3 equals 15. That gives me an answer of x equals 6. And the last one, 6 equals r minus 2 over 4. Leaves me an answer of r equals 26. Okay, so if you didn't get these right, make sure you review your work again, just to make sure. See if you can find your own mistake. If not, you want to go over it in class, put a little star next to it and make sure you raise your hand when I ask if there's any questions on the notes. Okay? Moving on. So, set builder notation, something we need to know. Set builder notation is a way of writing all the possible answers for a variable. Right now, we only have one, maybe two answers for the first couple of units. We will get into a point where we have infinite number of answers for what x could be or any of our variables or whatever we're talking about. So set builder notation is a nice way of writing all the possibilities. Okay, so for right now we're just going to talk about how to write it for our equations. So these are the symbols we're going to use. We use our braces right here. These are the curly little parentheses, braces. And we're going to go ahead and write those out. And then we put our variable. Here I just put x because that's the most common variable that you'll see. But whatever variable is in the equation, that's the one we're going to put right here. This line. And then we just write down what our variable is equal to. So x equals -7 or whatever we got for our answer. Okay? And the way that we read this is these braces mean a set. So the set of, really it should say of all x's. The set of x's, this line reads such that, and then we just say x equals -7. Okay? It's just a fancy way of writing all the possible answers. Okay? Alright, so example 2, put your answers from example 1 in set builder notation. These were our 4 answers from the first example. So here, all we have to do is do brace, x, line, and then x equals 1/4. Okay? B, same thing. Instead of having x at the front, we're going to have an m at the front. Brace, m, line, m equals 35. So the set of all m's such that m equals 35. Here, r such that r equals 5. Set of all x's such that x equals -29. Not really that bad to write this out in set builder notation. On tests and SOLs and stuff, some of your answers will be written in set builder notation, some will be written just like m equals 35. You have to be prepared for either way. Okay? The set builder notation just basically says anything can be x as long as it follows this rule that's after the line. Okay, so here the rule has to be x equals, it has to be at 1/4. That's the only possibility. There could be other rules like inequalities or stuff like that that tells us what x can be for other possibilities. Okay, so now I want you to try on your own putting your 4 answers from the first try on your own in set builder notation. So go ahead and pause for 2 seconds and write those down in set builder notation and then come back and check your answers. Okay, that wasn't too bad, was it? Alright, so our first answer should look like this. Set of all r's such that r equals -57. The next one should look like this. The set of all x's such that x equals 30. Oop, that should be a C right there, not a D. Next one is x such that x equals 6. And our final one is r such that r equals 26. Okay, if you have any questions on how to write this out or why we write it out, put a little star and I'll be happy to answer it in class. Okay, and I think that's it for this page. Yep, and then on to our last thing about identifying properties or justifying steps. Okay, not only with solving equations are you going to have to do it step by step on your own, but sometimes you're going to have to either justify your own steps, like why are you doing this? What says that this works? What says that you can do it this way? All those properties from the first and second page of your notes are the reasons why you're allowed to do it. People throughout history have been proving why this works. Okay, so we just have to use their proofs that they came up with. We don't have to reinvent the wheel. We just need to know the knowledge of it. Okay, so we just have to use that and say we can do this because of the distributive property. We can do this because of the inverse property. It says we can. Okay, so with these things, we just have, basically we're just saying, okay, what property was used to get from first line to second line? Okay, or what happened and what property is that? Alright, so first line, 74 equals x plus 3v. Sorry, I'm slowing down a little bit. And then we get to the second line, now it says 74 minus 8 equals 8 plus 3v minus 8. So the only thing that happened was now I have a minus 8 on both sides. what property did we talk about today that says we can have a -8 on both sides? Okay. It was the subtraction property of equality. Okay, it says if you subtract something from one side, you have to do the exact same thing to the other side. Okay, and to get from this line to the next line, to get to 74 minus 8 equals 8 minus 8 plus 3v, the only thing that changed, like nothing changed on this side. On this side, the only thing that changed was we moved the -8 in front of the 3v. So we just changed the order, right? Well, changing the order, that's commutative property, and it was over addition. So, like I said, that's why it's got a little plus sign on the end. Alright. The next step, well, we have a 74 minus 8 changing to a 66. We have an 8 minus 8 changing to a 0, and we still have the 3v there. Okay? Well, the 8 minus 8 becoming a 0, that's the inverse property of addition. Okay? But what happened with the 74 minus 8 changing to 66? What property was that? Okay? That's your substitution property, where you actually did the math. 74 minus 8 gives you 66. So if you want to put a little semicolon there for substitution, and then substitution after it, that would probably be a good idea. Okay, because that changed as well. Alright, then we have 66 equals 0 plus 3v, changing to 66 equals 3v. So the 66 didn't change at all, but the 0 plus 3v changed, and that's actually our identity property of addition. Okay? So, going from 66 equals 3v to 66 divided by 3 is equal to 3v divided by 3. Well, I'm dividing by 3 on both sides. That's, oh, this is a little weird. I'm dividing by 3 on both sides. This one should actually be down here, right? This should be the division of equality, right? Because I divided by both sides. Ooh, let's get that to actually fit. Division of equality. Okay? And then to get from 66 divided by 3 to 22, and 3v divided by 3 to get to v, that's the inverse property of multiplication. Okay? So that's what happened there. I want you to go ahead and try this on your own. Pause the video, try to justify these steps on your own. I will say getting down here is a little complicated, but that's not too bad. Okay? Alright, pause the video, and when you come back, I'll have answers for you. Okay, so not too bad. So going from first step to second step, that was the division or distributive property. Okay? Then going from here to here, I added 2 to both sides. That's the addition property of equality. My -2 and +2 became 0. My 61 and 2 became 66. So that's substitution. But here, that was the inverse property of addition. 4d plus 0 to just 4d is the identity property of addition. Here again, oh, see, this is what happened again. This is the division property of equality, because I divided both sides by 4, and then 4d divided by 4 gives me 1d, or just d. That's the inverse property of multiplication, and that didn't even change, so just the inverse property of multiplication. Okay, so please let me know if you have any questions in class. Other than that, that's all the notes I have for you. I hope you enjoyed them. If you're worried you're not getting these things regularly, go ahead and subscribe. Other than that, that's all I got. Have a good day. Bye.